Hello everyone. Today we are going to discuss about numerical aperture and acceptance angle. Firstly, we should start with working of optical fiber. When a ray of light is incident on core of the optical fiber at a small angle, it suffers refraction and strike the core cladding interface. As the diameter of the fiber is very small, hence angle of incidence is greater than critical angle. Therefore, the ray suffers total internal reflection at the core cladding interface and strikes the opposite interface. At this interface also the angle of incidence is greater than the critical angle. So, it again suffers total internal reflection. Thus, the angle of light reach the other end of the fiber after suffering repeated total internal reflection along the length of the fiber. At the other end, the ray suffers refraction and emerges out of the optical fiber. We can see that the light travel in the core is guided manner. Hence, the communication through the optical fiber is sometimes referred as an optical waveguide. Now in this diagram we will understand what do you mean by normal reflection, critical angle and total internal reflection. In first case we can see the light ray is incident in medium with refractive index mu1 and get refracted in another medium with refractive index mu2. Mu1 is greater than mu2. In second case, if angle of incidence is equal to critical angle, then the refracted ray will travel along the boundary of the two medium. In third case, if angle of incidence is greater than critical angle, then the ray will be reflected in the first medium. Now applying Snell's law, we will get sin I upon sin r is equal to mu2 upon mu1. At the start of the total internal reflection, I is equal to IC and R is equal to 90. Now using this value in the Snell's law, we will get sin IC upon sin 90 is equal to mu2 upon mu1. Solving it, we will get sin IC is equal to mu2 upon mu1 into 1. From this we will get the value of IC, which is equal to sin inverse mu2 upon mu1. Now, as we know that cos IC is equal to root of 1 minus sin square IC. Putting the value of sin from the above equation, we will get cos IC is equal to root 1 minus mu2 upon mu1 whole square. Now, following simple mathematical step, we will get cos IC is equal to root of mu1 square minus mu2 square upon mu1. When I is greater than IC, there will be no refracted ray. All the incident ray will get internally reflected. Now let's talk about acceptance angle or half angle of acceptance cone. The maximum angle when the axis of the optical fiber at which the light entering propagates through the fiber by suffering repeated total internal reflection at the core cladding interface is called the acceptance angle or half angle of acceptance cone. We can see this in the diagram. Let us consider a ray of light PQ incident at the air core interface at angle IC such that it is less than the angle theta A. All the angle are measured with respect to angle of the axis of the fiber. The face SR is perpendicular to the axis of the fiber. Let mu air, mu core and mu cladding be refractive indices of air, core and cladding respectively. such that mu core is greater than mu cladding, which is greater than mu air. Now let's solve it. Applying Snell's law at air core interface, we will get sin theta I upon sin theta r is equal to mu core upon mu air. Here theta I is angle of incidence at the air core interface and theta r is angle of reflection at the air core interface. Let phi be angle of incidence at the core cladding interface such that phi is greater than critical angle theta c. Now from figure, as we already discussed, that theta c plus phi is equal to 90, therefore we'll get theta r is equal to 90 minus phi. Substituting this value in equation number 1 and solving it using simple mathematics rule, we will get mu air sin theta I is equal to mu core cos phi. So we'll get mu air sin theta I is equal to mu core root of 1 minus sin square phi. When theta I is equal to theta A, then phi is equal to theta C. Again solving it further, we know that sin theta C is equal to mu clad upon mu core. Substituting this value in above equation and applying simple mathematical formulas, we will get the value as sin theta A is equal to root mu core whole square minus mu clad whole square upon mu air. As we know that for air, mu air is equal to 1. Therefore, sin theta A is equal to root mu core minus mu clad whole square. So we'll get theta A as sin inverse under root of mu core whole square minus mu clad whole square. This is expression for acceptance angle of optical fiber. Now let's discuss about numerical aperture of optical fiber. The figure, or we can say numerical value of merit, which describe light collecting ability of optical fiber, is called numerical aperture. Thus, light collecting capability of optical fiber is directly proportional to its numerical aperture. Numerical aperture for step index fiber can be written as NA is equal to mu air sin theta A. Putting the value of sin theta A and solving it, we will get NA is equal to root of mu core whole square minus mu clad whole square. The largest possibility value of numerical aperture is unity. Now, numerical aperture for step index fiber in term of relative core cladding index difference, del, which can be written as del is equal to mu core minus mu clad upon mu core. Now, solving it by using simple mathematics rule, we are going to multiply and divide the del value with mu core plus mu clad, and again solving it, we will get del is equal to mu core whole square minus mu clad whole square upon mu clad in bracket mu clad plus mu core. For an optical fiber, the difference between the refractive index of core and cladding is very small. Therefore, we can write mu core is equal to mu clad. It is an approximate value. Now, using this in the value of del and solving it, we will get del is equal to mu core whole square minus mu clad whole square upon twice mu core whole square. Again rearranging the term, we will get mu core whole square minus mu clad whole square is equal to twice mu core whole square into del. As we know that numerical aperture is equal to root of mu core whole square minus mu clad whole square. Therefore, the numerical aperture can also be written as root of twice mu core whole square into del, which can simplify it as numerical aperture is equal to mu core root of 2 del. This is an expression for numerical aperture in terms of relative core cladding index difference. For graded index fiber, numerical aperture is equal to sine theta c. So in this way we have completed the topic. Thank you.